Okay, let's take a look at section 2.3 worksheet on function notation and applications. We're going to write the function using function notation. We're going to let x be the independent variable and y the dependent variable. We're going to use the letter f to name our function. So 4x squared minus 2y equals 100. We want to solve this for y, which is our independent variable. We're going to subtract 4x squared from both sides of the equation. That leaves negative 2y equals 100 minus 4x squared. Divide each term by negative 2, and we get y equals negative 50 plus 2x squared. I replace y with f of x. So that tells me that the function's name is f, the independent variable is x. And that equals to what my y equal to, which is negative 50 plus 2x squared. And that completes what I was told to do in the problem. Now we want to write the function using function notation. Again, we want x to be the independent variable, y the dependent variable, and the function to have f as its name. So we're going to clear the fractions by multiplying by the LCD, which is 6. So that's the smallest number that 6 and 3 divide into evenly. So I'm going to multiply 6 by the terms of my equation. So 6 gets multiplied by 10x squared plus 4 over 6, and it also gets multiplied by 5y minus 8 over 3. And the whole point is that each denominator is going to divide evenly into that LCD I multiply by. So 6 in the denominator divides into 6 that I'm multiplying by one time. So when the division gives 1, I leave it unwritten, and I'm left with 10x squared plus 4. Now on the right side, I'm left with 2. Since 3 divides into 6 twice, I'm left with 2 times 5y minus 8. Using the distributive property, the right side becomes 10y minus 16. I want to solve for y. My step in doing that will be to add 16 to both sides. And I wind up with 10x squared plus 20 equals 10y. I divide each term by 10, and I get x squared plus 2 equals y. So x squared plus 2 is f of x. I replace the y with f of x. In number 3, I'm doing the same thing. I want to rewrite this in function notation where x is the independent variable and y is the dependent variable. And I want to name my function f. So in this case, I'm going to subtract 6 times the square root of x minus 5 from both sides of the equation. So on the left side, though that radical expression drops out, on the right, I get negative 6 times the square root of x minus 5. I divide both sides by 3, and I get that y equals negative 2 times the square root of x minus 5. I replace y with f of x, and now I have my function notation. F of x equals negative 2 times the square root of x minus 5. All right, so the next thing is to evaluate functions. So h of x is 2x squared plus 5x minus 17. I want to evaluate h of negative 4. So I replace every x with negative 4. So 2 times the square root of negative 4 plus 5 times negative 4 minus 17. When I raise a negative number to a power, I have to parenthesize that negative number. So the square root of negative 4 is 16. 5 times negative 4 is negative 20. So I have 2 times 16 minus 20 minus 17, which equals 32 minus 20 minus 17, which is 12 minus 17, which is negative 5. So h of negative 4 is negative 5. Similarly, I want to evaluate c of x equals square root of 25 minus x squared when x is 3. So that means I want to find c of 3. So that's the square root of 25 minus 3 squared, which is the square root of 25 minus 9, which is the square root of 16, which is 4. So c of 3 is 4. Okay, now I want to graph this function by plotting. One of the things I need to know is since this function involves absolute value, it's going to have a V-like shape. That's the shape of the function which equals the absolute value of x. Ours is going to look a little different because of the plus 1 and the minus 3. One point I want to show is the point whose x-coordinate causes what's inside of the absolute value to go to 0. And that's the point whose x-coordinate is negative 1. So f of negative 1 is the absolute value of negative 1 plus 1 minus 3, which is 0 minus 3, which is negative 3. I want to find a point. So this is going to be the sharp corner on the graph. And I want to find a point, so when x is negative 1, I'm at the sharp point of the graph. So I need a point to the left. So 1 unit left of x equal negative 1 is x equal negative 2. F of negative 2 is the absolute value of negative 2 plus 1 minus 3. Absolute value of negative 1 is 1, so I have 1 minus 3, which is negative 2. So I'm going to plot the point negative 2, negative 2. Now I want to find out what is f when x is 0. So I have the absolute value of 0 plus 1 minus 3. That's the absolute value of positive 1 minus 3. Absolute value of positive 1 is 1. So this is 1 minus 3, which equals negative 2. So I have 3 points I'm plotting, and I have to strategically pick those for this function. I always want to show the point where the graph turns around. That's the sharp corner on the graph. In this case, that happened at the point negative 1, negative 3. That always happens when what's inside of the absolute value expression goes to 0. So I plot my 3 points, and then I draw lines through them, remembering that this graph continues forever, going upward and right when I'm on the right side. When I'm on the left side, I continue upward and go left. And so notice the graph that I get is a V. So in this case, different from the parabola, this lowest point actually is the vertex. I mean, you could call it a vertex, but it's really the sharp corner. And I want you to notice that f of x shifts y equal absolute value of x 1 unit left and 3 units down. So these two functions have a graph that looks the same, but to get capital F, I actually shift the graph 1 unit left and 3 units down. Every point on the graph of y equal absolute value of x has been shifted 1 unit left and 3 units down. Here we have a graph that represents the profit of a company that makes fishing rods. So the y-axis represents the value in dollars of the profit. The x-axis actually allows me to relate x and y to each other using a picture. So I want to know if the manufacturer produces 7,000 fishing rods per year, what is the expected profit? I just look at the graph to see that the expected profit is $150,000. So when x is 7,000 on this graph, y is 150,000, which gives me my profit. All right, now I want to find the intervals of increase on the function. Notice that I'm shading the portion of the graph that goes uphill. That's when I'm on an interval of increase. So notice from x equals 0 to x equal 4,000, the function is increasing. So I write that using interval notation. I'm going from 0 to 4,000. And when I'm giving intervals of increase and intervals of decrease, I never use the square bracket. All right, so now I see there's another interval of increase that I've shaded, and that occurs from 6,000 to 12,000. 9,000. 6,000 to 9,000. So I unite these two intervals. And notice how it's the x values that determine the endpoints of the interval. Whenever I'm doing intervals of increase and decrease, I won't be including my endpoints, so I'll always be using parentheses. Now let's find the intervals of decrease. So I'm shading those with green. The function is decreasing when it's going downhill. So I've now shaded in green the portion of the graph that's decreasing, where profit is decreasing. So the intervals of decrease, the first interval is from 4,000 to 6,000. And I unite that with the other interval of decrease, which is from 9,000 to 12,000. All right, I want to find the maximum profit that can be expected in a year. And notice that that's the highest point on the graph, which is 300,000. So that's my max profit, and that corresponds to x equal 9,000, which is the number of rods that are produced. Now I want to use this information from Part D to find the average profit per fishing rod produced. So I divide the profit, 300,000, by the number of rods, which was 9,000. And I can use my calculator and do that, and I get $33.33 is per rod is the average profit if 9,000 rods are made. So the average profit per rod is $33.33. Now I want to find the average profit per fishing rod if the manufacturer produces 4,000 rods per year. So I go on the graph and I find the Y that corresponds to 4,000 is $210,000. That's divided by the 4,000 rods. And that actually gives me $52.50 per rod as my average profit. So now the question is, if you were the company's chief executive officer or CEO, how many fishing rods would you have produced? Explain why you gave this answer. Well, even though producing 4,000 rods gives an average profit per rod of $52.50, which is greater than the So even though producing 4,000 rods gives an average profit per rod of $52.50, which is greater than the average profit per rod of $33.33 when producing 9,000 rods, the most important thing is to achieve the greatest profit, which is $300,000, and occurs when 9,000 rods are produced. So the CEO would produce 9,000 rods to achieve the greatest overall profit of $300,000. So notice that average per rod profit is much lower, but the overall is what a company is going to be interested in. Okay, so here we have a description of a purchase of a stock by Bill. So on the vertical axis, we have the value of the stock in dollars. And on the horizontal axis, we have the day or days since the purchase. So we look at the day of purchase as day 0. So we're going to take the information and translate it into points that we're going to put on the graph and connect with a line. So Bill bought stock in a company for $10 per share. So each point is going to consist of a first coordinate, which is the day that we're on, and a second coordinate, which is the stock value. So the day that the stock is purchased is day 0. The value at which the stock was purchased is $10. After the purchase, the price remained constant for 2 days. So we had 2 to 0, so we're on day 2. And constant, remaining constant, means the value of the stock is still $10 per share. At that time, a negative report was released about the company. So the price declined steadily for 3 days. So I add 3 to 2, so now I'm on day 5, until it had lost a total of $6 per share. So I subtract 6 from 10 to get 4. The price remained steady for 4 days. So I'm now on day 9. I add 4 to 5 to get that 9. Remaining steady means there's no change in the value of the stock. So we have the 0.94. Then a positive report was released about the company, so the price rose sharply for 2 days, gaining $8 per share. So I add 2 to 9 to get 11, and I add 8 to the value of the stock to get 12. So I'm at the point 11.12. The price continued gaining gradually for 4 more days, ultimately rising $1 more per share. So I add 4 to 11 to get 15, 1 to 12 to get 13. At that point, the price began to decline slowly for 6 days, losing $2 per share. So I add 6 to 15, which is 21, and I subtract 2 from 13, which gives me 11. So those are the 7 points that are going to allow me to tell this story with a picture. So I start by plotting the point 0, 10. So that actually lies on the vertical axis. Then I plot the point 210. Then I plot the point 54. Now I plot 9, 4. Eleven, 12. Then I plot the point 15, 13. And now the point 21, 11. And I'm going to have to move off of the graph to have 21 days. I didn't mean for that to happen. I'll just put a 20 here. And 21, 11 will be just 1 unit over. Typically I make these where you have enough on the graph to keep everything on the graph. So I messed up a little bit here. Alright, so I am going to connect these points with a line. And notice how the story is told. If I was doing this on paper, I could actually use a straight edge and write this much better. Okay, so I went in and cleaned up those lines, but this shows us a beautiful picture, and we can see very clearly that the price started at $10 per share, decreased over, wait a minute. Okay, here's the picture because I lost a point when I was trying to put in straighter lines. All right, here's the actual picture. So the stock was purchased at $10 a share. That's day 0 when we make the purchase. The price remained steady for 2 days. Then the price decreased over a 3-day period all the way down to $4 per share and remained steady for 4 days. Then increased up to $12 a share over 2 days. Then over 4 days increased to $13 a share, and then decreased over 6 days to $11 a share. And so the picture is very easy to see when you have a picture. When you look at all of these words, it's a lot harder to clearly see what's going on. But I think the picture is more readily understood and more quickly interpreted.